Hello, everybody. Welcome back. Welcome to the third week of the semester. Third? How do I forget already? Yes. Welcome to the third week of the semester. So, I guess, what do I need to say? You need a group. You need a group real soon now. I assume I've sent an email about that since I have it drafted and just have to press send as I record this. What else we got? I don't know. Do the exercises. And once again, the first thing that groups need to worry about is the technology evaluation. What topics do you want? Because the things compress in there and we do need to get that sorted out as soon as possible. So talk to your group about possible topics for the technology evaluation, but I'm going to give a lecture. Okay, so I was talking about HTTP status codes as I left off last week. So again, we have this protocol that is the web, HTTP. Again, I'm kind of saying all of this as if I'm talking about HTTP 1. It all applies equally well to HTTP 2. It's just spelled a little bit differently. And I've got the reference here just in case I need it. So I think I talked about the 100 series last week, which is, I guess, like again, like switching HTTP 1 to 2 to Speedy to 3, maybe you would see this switching protocols where the server can come back and say, oh, you said you want HTTP 2? Okay, well, we'll upgrade to that. Sort of after that first request, I guess. But, okay, I should have watched the video, but I do have a memory of talking about these. Again, 200 OK is the one that we saw sort of the most often. Like when I was doing demos last week, it's one that we imagine is going to happen most of the time, but well, maybe not. Maybe it's not the sort of best case scenario, and we'll talk more about that today. And then again, partial content, if you're getting a response and it dropped, right? You got the first part of the file for whatever reason as a user agent. You could then say, okay, well, only give me the part of the file I don't have, right? So, I saw the first 1,000,000 bytes. Please start at byte 1,000,001 and continue from there. And then the server could, again, in that case, the server can say, I don't know about this partial content business. You want this file, here it is. Or it can say, oh, okay, I will send you the part of the file you asked for. Here's byte 1,000,001 on. Okay, so what we, again, these are some of these things that I guess, I think, again, make you a better web developer if you know that these are things that can be said in between client and server. So if you look at the 300 series codes, I don't think I want to say anything else about 200s. The 300s are sort of categorized as redirection. I don't think this one sounds like redirection. I think probably the 300 codes, like in my mind, are the server and client are going to have this little conversation, and the user doesn't have to know about this, or doesn't have to do anything about this, I suppose. I'll talk about caching more later on, but this is, the browser has said, you know what, I have this URL in my cache, can I just use it? And the server can come back and say, yep, you have a cached version of this resource. It's exactly as good as what I would send you anyway. So 304 not modified. So we get the headers, like we get, a response and some headers back with some meta information, but we don't have to send the actual image, HTML, whatever it is. And I will come back to caching. And then there are these 300s that actually sound like they're in the right category, the redirects. So these are all things that the user, well, I guess they see if you sort of look carefully enough. Do I have the, no, I don't have my up arrow from last week. Well, let's go for like this URL. So one thing that I will point out, and the reason I know that these redirects work, I'm going to type this URL without a slash on the end. and then I pressed enter and I got a slash on the end. So the reason that works, well, I don't know if no, because it's going to time out if I start to type thing. Okay. I will compose my query first. Okay. I guess that's all I really need. Okay. Oh, this isn't going to work because I have to make an HTTPS request to this server. I guess I'll get a redirect, just not the one I was expecting. So this is, I made an HTTP request and I got a 301 moved permanently response to the S version. And that's just server setup that non-HTTPS requests get redirected. So yeah, it was that one that I just saw. I guess if I sort of continue down that path, I would get the one with the, no, what you meant was this URL with a slash on the end. And those will both be permanent. There's the temporary versions, 302 and 307, that are, well, as far as the user is concerned, the same. And they both come back with, well, they all four of these come back with a location header, and the browser automatically bounces there. So again, this is the user doesn't have to know about it deal. The browser just takes them there. And then the see other, which is the like, well, I don't have that URL. I don't have the URL you wanted, but I do have a URL that I've been configured to send in this case. That's, you know, somehow reasonable replacement information. So in a technical way, these are all kind of the same, send the user. There is a semantic difference between them, right? Like, so I would imagine, you know, citation needed, but if Google hits a URL, like the Google bot hits a URL, it sees a 301 move permanently. Well, that's a sort of, you know, update the database. This is the new URL for this content. The temporary redirects would be, okay, well, I'll keep the old URL, but I'll index the new one and see how that goes. The two things that are both effectively temporary redirects, I don't want to read a Stack Overflow page, but one of them is if it's a post request after the redirect, it will still be a post request. That's 307. And 302 is if you made a post request and get a response, then the redirect will be a get request. So it's a 302 that allows that post redirect get pattern. So it's basically, does the method survive the redirect or not? It's a bit of a fine distinction, to be fair. Okay, wait, what else? Do we have anything else in the 300s? Multiple choices is for content negotiation, which I will talk about later. 302, 304 I talked about. Use proxy, sure. Yeah, I think that's good. I think it's all I want to say about those. Okay. The 400 series are basically like you did something wrong, like the user did something wrong. Or somehow, you know, the thing the user did is not recoverable. So something like this, right? So you come along to some URL, maybe because you made up the URL because you're trying to see something you shouldn't, or maybe because, you know, you just found the link or whatever, but you can't do that for, again, whatever administrative reason on the server side. 404 not found is, of course, something we all know and hate. Maybe one thing I will say here is, like, this is not, like, a user should never see a 404 because of something you did as a developer. Yeah, like if the user comes along and just types some URL, okay, well, fine, you can't help that. But if there was a URL that worked yesterday, it should, if it went somewhere, you know, permanently or temporarily, or it's been replaced with something similar, that's what should be returned at that URL. If it is genuinely information that's just not there, like we had to stop publishing this page, there's the 410 gone for that. So, like, again, this is something like if your users are seeing 404 not found, you have done something wrong as a developer, usually. Right, sorry, over here. Again, anything else? There's a 401 unauthorized. That's that sort of old school like authentication where you get a little pop-up that's like username and password that is done by the browser, and the browser sends that username and password back. You don't really see it. Like, I can't think of the last time I saw that style of authentication, so let's just assume we don't use it anymore. Not found. Sure. You could perfectly reasonably, I mean, you might have some kind of web application that is doing, you know, you have GET requests and POST requests, and maybe you have a REST API where puts and deletes and patches are coming in. Well, you might have URLs where it's like, this is read-only. You can get this URL, but you can't post to it. It's just not a thing that's allowed. And you can send a sort of more informative response back. The not acceptable, again, I think a little bit more common in the like REST API case where somebody is requesting a certain piece of content like as XML or something. And we can't generate XML, we can generate a JSON version of this content. But again, it's basically, we can't satisfy all of the accept headers. And well, I'll talk about accept headers real soon now. Yeah, I think, again, API related, length, yeah. Yeah, various forms of like, almost like syntax error style of things. Like you have tried to make a post request where the post data is so big we can't deal with it, or you requested, you know, that get line, that request line of the URL has this hugely long URL, and it's like, look, we're just not going to. Oh, okay. So I mean, I talked about that like partial content 206. So if a client can send a request and say, I want to get bytes 1,000,001 to 2,000,000, well, what if it's a small file? So the server can come back and say, you have not requested something sane. I cannot send you those bytes in this file. They don't exist. Which again, if you're creating some piece of software that has a, you know, sort of large file downloads, maybe knowing about those is worth it. Most of the time, you're probably not going to worry about it, but hey, it's good to know they're there. So the 500 errors are server-side problems, right? So the 400 were client-side problems. The 500s are, you know, the client probably did everything just fine. There's a problem on the server side of things, with the most generic being the 500 probably. Very often, like a web framework or something, if your code throws an exception, that gets translated to a 500 internal server error by the time the user sees it. I know full well from experience, like, because I get emails when certain servers send 500 internal server errors, because again, it's a programmer's problem. It shouldn't happen. Users will just slam Control R on that page, hoping to get a new answer. And I get an email every time. It's great. I'll talk about reverse proxies, gateways, caching, like all of those things later today as well. And these two are like, there's a front end server, you know, the actual thing that is running the web server that you can see as a user, and it's talking to somebody behind. So there's some other application server or collection of application servers doing the work. They're not there. So this is it's like there is an internal server error, but the front end server is saying, but I didn't do it. That back end server is being slow. Don't blame me, is sort of the semantics there. I mean, and you'll see this once in a while on like, you know, mail.sfu or go.sfu or something, where they have a load balancer or something or other in front. the backend server is just taking a break, whatever. Or again, the more informative version, we have taken this thing out of service. We've just decided to turn it off for maintenance or whatever. Again, are there any here that I didn't put on the slides that I want to talk about? Yeah, probably not. Oh, sure, HTTP version non-support. All right, so sure, I guess you try to make an HTTP 2 request to an HTTP 1 server, although I don't even know how it would understand the request well enough to return this, but maybe they're planning for the future there. Okay, so I think that's what I want to talk about there. And again, it's not that I care, like if there were tests in this course, it's not like, what's 503 service unavailable is a question I would ask. But knowing that 503 service unavailable is a concept that exists and that your web server can produce if you need it to, that's important. Or again, there are times as an application developer when the thing that I want to return is a 403 forbidden, not a 200 okay with a message that says, sorry, I can't show you this information, but a 403 forbidden with a page saying I can't show you that information. It's subtly different, but the browser is going to respond the right way to that information. Maybe I'll keep that just in case. Okay, I keep saying web server, and I think you probably know what a server is. But again, client is in HTTP speak, the user agent, the web browser, or like wget or curl or whatever it is. You'll see, I guess, some up in exercise 3. The server side is, of course, the other side of that conversation, the thing that's sitting there waiting for requests to come in so it can send a response. And in our world, speaking HTTP back and forth. So the world of HTTP servers is kind of broken up into 2 categories. The sort of front-end servers, like these ones that are probably the one facing the user. So, if you go to, well, I don't know, w3.org. Well, let's find out. So this looks like it was probably an HTTP 2 response. Is there a server header? Oh, they have it. They have stripped. They have not given a server header. Often there is one to say what's there. Let's see about. Did I have one there? Yeah. Okay. So this server, at this moment is running Nginx version whatever. So that's a piece of software that's actually sitting there listening on port 80 and 443 for HTTPS connections. And is doing this work. So for years and years, like, possibly 20 years, Apache was the choice. Apache is very, very flexible. Every trick that's possible for a web server to do, Apache can do it, I think, no question. But it's not the fastest thing. So yeah, so Apache being the blue line here, yeah, was the most common server from like the late 90s through, actually even more recently than I thought, like into like 2015, 16. Okay, it had a good run. The one thing Apache isn't is super, super fast. Nginx is designed to be fast, or I guess has more focus on being fast. Maybe I'll say it that way. I don't know what this little blip of Microsoft IIS servers is. I suspect that has a lot to do with like some version of Windows turning it on by default, and a lot of this might be somebody's cable modem or something. I find it hard to believe that 50% of the web is Microsoft IIS. And Nginx becoming, again, I think, and certainly I think would be the default choice for me by far at the moment. If you're really in a Microsoft world, and you think, world-class free web servers are too free, I guess, sure. So again, those three are, again, probably the most common choices for something facing the user. When the user makes a request from the outside world, that's what they hit. And then there's all of these like application servers that are, I guess, running code more likely. Those are the things that we'll talk about later. And frankly, the things you will interact more with as a programmer. As a programmer, you're probably not touching Nginx very often, but you are dealing with Node or something like a unicorn or WSGI or something like those kinds of words that are around the application servers. What a web server does is, again, in some ways simpler than other servers. HTTP 1 at least is just this nice text-based format, really easy to understand, but it's more complicated here in the sense that there's just kind of more for it to do, more choices, more configuration on the part of a web server. If you're setting up a like SSH server, it's pretty much you can log in, right? And then there's a shell, or you can share files, right? So from what directory? There's not much configuration to those. Web servers have a lot of different ways that each individual URL might get served. And well, let's talk a little bit about that. I'm going to divide the world up here into static and dynamic content. And almost everything I say for the rest of this week is going to be like, well, for static content this, or for dynamic content that. Static content is roughly a file, right? So there's no logic there, right? There's no like, I have to run this program and decide what to do, and it might look different in 5 minutes. It's just, here's a file, and it's on a disk, and it has a last modified, and that's all there is to it. So what you're doing in exercise 1 and 2 is that. Here's just some HTML, some CSS, some images, whatever they are. We're imagining, I guess I'm not actually making you put them on a web server, but we're imagining they go on a web server. And like this page that you're looking at is static content. There's not really any way to know that as a user. But I'm telling you, like, I generated some HTML file and uploaded it to a server. That's how this page came to be. And that's easy. And of course, it's an easy job for the web server to deal with. Find the file, send it. Right. So when that request comes back, okay, so the server has to generate the response line and the headers, and then an extra new line character, and then just dump whatever contents were in the file out the HTTP connection. Dynamic content is dynamically generated. So basically, like some code does it, right? So instead of just finding a file on a disk, run a program. The program produces some output somehow, and might be different, right? Might be different for each user, might be different in 5 minutes. Whatever this program does, that's what the content is going to be at this moment. And like I said, as a user, you can't really tell. If I hit the SFU front page, is there an HTML file on a disk with this words safety plan in it, or is there a row in a database that with these things, and something just read a bunch of rows from the database and assembled this HTML when I hit that URL? I don't actually know. I could maybe guess sometimes. Well, certainly if I go to that URL and you go to that one and we get different things, I would pretty fairly guess it's dynamically generated. There's nothing here that says like, welcome Greg Baker or anything. I suspect it could be static. I don't know. So this is a thing where web server configuration becomes a pain. And so that's something you're going to deal with in like exercise 4, and then what is it, 7, 8 or something, 9, some subset of 7, 8, and 9. There's just this configuration of like, well, how do we do it? And even if this page is dynamically generated, which I kind of suspect it is because we have some content management system that does it, This file that's just jQuery, I bet, is static, and they come from the same server, right? So this thing called www.sfu.ca has to know that, like, okay, this URL and this URL have to be dynamically generated by running this code. This URL has to be is static, and it comes from this file over there. So that configuration is painful, might not be the word, I guess. Can be more work than I think people expect. It's just, yeah. And of course, there's the part of the problem is, like, every combination of web server, Nginx and Apache and IIS, and then, like, what programming language or framework. So it's, I'm doing Python and Django, or I'm doing Ruby and Ruby on Rails, or I'm doing Node with Express.js. Like, there's this, like, all possible pairs configuration that you have to work out, and it can be a challenge, especially if you have sort of an uncommon pair. So this is another where I think, like, as a programmer, which is, I assume, going to be your role in most sort of web development that goes on, the dynamic content is the stuff a programmer is going to worry about, because, well, that's where the programming is. Programmers tend to not worry much. Like, so even if whatever page here is dynamically generated, programmers tend to worry about the code that generates the page. They don't worry about things like this image, which is probably static. Probably, I would suspect. Maybe a program had to do some work and find this thing and, like, scale it, or maybe it's on the fly composited with this man whose shadows don't match his position. I don't know. But, and I see developers do this, where developers are, of course, worried about the code that they're writing, not all of the other stuff that's, oh, that's just content. Just content can really slow your site down, and I will talk more about that later on as well. So one of the things that I guess I mentioned a few minutes ago, but that can happen here again, is this distinction between the, like, I guess, front end and back end web servers. So again, there's the web server that is, you know, it's known as www.sfu.ca or whatever, that the user talks to. That one's not going to do the real work, right? So if this page has to be dynamically generated by taking some template, doing a bunch of database queries to decide, like, what goes here, who has set this up, or maybe this is the page that I see because I'm in Burnaby. Maybe if I was visiting from elsewhere in the world, I wouldn't see this safety plan, because if I'm an international visitor, like, maybe I don't care about the campus safety plan. I care more about recruitment. Maybe. It's certainly a thing that could be done by dynamic content. Whether our website does it or not, who knows? That can be the point here. That can be a lot of work. So I might have one web server that's sort of facing the world, and then an application server, or maybe a bunch of application servers sitting behind that, and all the front end server is doing is saying, well, oh, I got this request. You know what? That's dynamic content, so you do it. One of these application servers is going to actually run the code that, again, does a database query, does a bunch of string concatenation, whatever, generates this HTML. And then just sort of, again, the front end server has a very dumb job to do, pass the bytes back to the user. So that story that I just told, I think all of these terms apply equally well to it. And people use these terms slightly differently and in slightly different contexts. But I think within any reasonable definition, I think I would treat them as synonymous, that, well, the front end server that the user sees is the gateway server or the reverse proxy or the load balancer. Again, subtly different terms, but that's really what we're talking about, where we have a server the user sees and then a one or more servers behind it that are doing sort of more intense work. And again, I keep the problem is all of these topics are like circularly dependent. So I've been talking about server-side programming without actually talking about server-side programming. But these are the things where, again, you write some code in possibly with some framework. It runs on the web server. So this is code that the user never interacts with directly. They might see the results of this code, but they don't see the code. They don't run the code. You run the code on the server. Where, again, the other side of that is the client-side code, JavaScript, maybe WebAssembly, but things that run in the browser. So server-side programming is like a big part of what we're talking about in the course. There is a big collection of tools, and I guess when it comes to the project, especially, you have this choice. So you can decide, your group can decide the Snap framework is where it's at. That's how we're going to do our server-side programming. And how do you choose? Well, hopefully your classmates will help you out a little bit on that. So, like, I have broken the world up here, and again, I think I have maintained this list reasonably well. So I don't think there's too much on this list that's too dead, and I don't think there's too much on this list that are like missing from this list where there's like server-side frameworks that are actually getting action that I haven't included. Okay, Web2Py might be dead, and I'm not sure if where did it go? The Java thing. Struts. Like, I'm not sure if Struts is an actual active project or not, but it's definitely, well, I mean, they're offering a GitHub repo. So, well, people are actually committing as of at least a couple months ago. So yeah, maybe it is alive. I don't know. So yeah, this first category are all things that help you write code that run on the web server end of things. And then the other category is collection of things that help you write code that runs on the client side of things in the web browser. So presumably some fraction, half or so, of the technology evaluation topics will be server side. It's going to depend a little on your interest and what the groups in the course choose. But I will admit at this point, like, I don't know all of these. Like, I know Django reasonably well, Rails a little bit. I have looked at some of these other ones enough to know that they seem cool and all, but the list is too long. Like, I've never written Symfony. Like, the PHP world seems to really like Laravel in recent years. I've never worked with it. I'm sure it's nice. So this is why I'm outsourcing the technology evaluation is what I'm saying here. I'm making you do it because it's just not possible for one person to know any reasonable subset of all these tools. So there is this, I feel like this almost mysterious process for a lot of web developers of, okay, I wrote an if statement or whatever, and then I hit a URL and somehow that if statement ran. That's this sort of connection, and it comes in a bunch of different ways, and it's going to depend a lot on, frankly, which thing, because a lot of these are language specific. Sometimes they're actually framework specific. Very occasionally they're actually server specific. So it's like, if you have like Microsoft IIS, you have to talk to it this way or whatever. So I'm going to do a quick example. WSGI is the Python web server gateway interface. So it's Python specific, and it's a way that my Python code can talk to a web server. Or I guess maybe I should say it the other way. Like, a web server that's sitting there waiting for a request to come in can be configured so that these URLs ask this Python code what to do. Okay, so I am going to, well, in fact, you know what? I think I had the foresight to download this. I didn't. Again, this is I downloaded it in the other account that I log into in this computer that has all my like various alerts that go off, and I don't want them to go off during a lecture, so I log into this account. And anyway, this is why I appear to be not prepared for lectures. And that thing not upload? How did that happen? Okay, I'm going to pause and find that damn file. I typed the URL wrong. Okay, this time for surezies. Okay. It's whiskey demo. Okay, so this is a complete file. I left a couple lines off the slides. But the idea here is, so WSGI is a fairly low-level tool. Like, you as a Python developer probably aren't going to write this code. Somebody who creates your framework, the Django or Flask or Web2Py developers are going to write this to bridge across to your code. But conceptually, this is all that happens, right? So you write a function, and the deal is when a request comes in to the web server can call this function somehow, you know, with whatever bit of mechanics are in between, like Nginx and this line of code. It will give it the collection of environment variables. So like, you know, all the environment variables that, and those specify a bunch of things like it's a GET request, it's a POST request, what are the HTTP headers, if it's a post request, how can we find the message body that was sent, that kind of stuff. And here's a function that can get started. So you get to do some work, and then you basically send the status code and the headers. Then you, the developer, can decide basically what does the file look like. So the only other thing here, like, I have this development server. So this isn't something you would do in a real application. This is something I would do for development so I can see it work, but I want to see it work. So I do that. My development web server is presumably now running. It's running on port. Sorry, I can't think about ports and type at the same time. I think it's on that port. Yeah. So that code generated that response. Okay, so there was a couple of things that were, a couple headers that were added automatically. Oh, it actually figured out the content length automatically. That was nice of it. I got to insert that header because I said so. And then the content. I guess, you know what, maybe if I put a new line on the end of that, it'll just read a little nicer. Oh, right. There we go. But that was it. Maybe one thing I will point out here, the content is bytes. It's not characters, and I'll come back to characters versus bytes in a little bit. But my emoji came through okay. Just what that Unicode character is. But yeah, I think, again, this is the basics, and it's going to be, this sort of thing is going to be equally true like for Ruby on Rails code with, I forget what the Ruby equivalent is. Or no, for JavaScript, Node.js just sort of runs as a web server, and that's the interface between the front end and back end web server, is just usually an HTTP request. But it's basically, I now have a chance to write some code. I can write whatever logic I want in there. And again, it's probably going to be, like in reality, it's going to be something like, call the function that's in the Flask framework that actually can generate a response and do all of the stuff that that framework promises. But this is, as conceptually, all that has to happen. I get to write code to generate the content and the headers, so I can generate whatever I want based on, well, I know how to program. So all the input there is the request, which again, I guess I implicitly said here, this environment that comes in describes the HTTP request. And I guess I could see it, couldn't I? And I could compare and contrast here. Nope. Okay. In the browser versus there. I guess this is one nice part of being at this like very low level. I can just do that. Let's have a look. What does that environment look like when a request comes in? Well, there's a lot of it. It has information like, okay, so it's the complete environment, including like just my login session here on this computer. Okay, it contains stuff like this, right? So these kinds of path info, there's a really important one. What was the part after the host name, right? So I can request that URL. At the moment, my web server doesn't care or do anything about that string, but it is there. It is input that comes in. So somebody is going to have to like parse that string and figure out, okay, well, for this path, here's the thing. Or if it's a GET request to that path, here's what we're going to do about it. I don't know what else we see here that's interesting, but that's the idea. Oh, and I guess I didn't actually compare and contrast there, but if I loaded the thing with a web browser, it looks pretty similar. I guess I do have, again, so that was a request header. Like we'll talk about the HTTP accept header in a few minutes, and accept language. Like all of those request headers get passed in as part of this dictionary into my code. So that's all the input I get, basically. And the output is, again, effectively, I'm building an HTTP response here. I'm doing it by saying like, okay, send this status code and these response headers, and then send all of these, like, so this is a list or iterable of some kind of, here's all the content. And then be a programmer. In some sense, the course is done at this point, right? This is kind of all you need to know about at least the server side of server-side programming. There's a way, this one for Python, Rack. It's Rack for Ruby, again, Node for JavaScript, but you have some way to talk to a web server or have a web server talk to you and say, hey, this request came in, what should I do? But nothing's ever that simple. Because, I mean, even something like, what did I, like somewhere back here, right, wherever there was this path info, okay, I'm going to have to disassemble that string. I'm going to have to say like, okay, well, here are all the parts of the string, or I need some way to say like, okay, well, when this kind of request comes in, when I get a request for a URL that looks like this, call this function. When I get this URL, call that function. All of those things have to get done. And I have to do them, and you have to do them. Like everybody that writes server-side web code has to deal with something like that. And then we all have to like make some database queries and say, okay, well, I want, you know, all of these things, all the things like this for this user, whatever. All of us have to turn basically data structures into HTML, right? So fundamentally, whatever I might do over here, I'm not usually just going to have a string and say, here's your content. I'm going to have, well, even if we look at like this page, you know, I'm willing to bet somewhere in some database, there's a thing that says like current front page headline story. What's it, you know, and there's like a title and a body and a learn more URL. And it assembles those pieces into an H2 and a paragraph with a link in it. That's totally sensible markup for that content. Somehow those fields that came out of a database as like one row in a database have to get turned into that markup, probably with an HTML template. So, well, and again, common theme, I guess even, I was going to say in web development, in modern programming in general, hey, we all have this problem. Why don't we not all solve it separately? Why don't we create some toolkit to help us? So again, back towards the technology evaluation, these things, and of course, all of their cousins and competitors are doing that. And if you look, I don't know, the play framework has a bunch of logic that lets you say, well, here's what URLs look like, and these URLs connect to that logic. But they all come down to basically something like this. When a request comes in, what do? It's just a program. Okay, what time we got? Yeah. Okay, this is one. Okay, I do kind of miss this. Oh, hey, future Greg, do a poll in the YouTube chat for those watching live. And the question I will have here is, do you feel like you know what a character set and a character encoding are and what the difference is between the two? And like from experience, when I say this in a class of however many of you there are, there's been like two people that like kind of cautiously put up their hand, and 98 people that quietly slink down in their seats and hope that they're invisible in case I'm about to ask them what the difference is. This is an important thing that like somehow nobody talks about. You shouldn't have had to wait this long to have this talked about. It's too important to modern computing, and it's easy to get wrong as well. So the problem here is this kind of thing. Okay, I mean, it's a picture of a newspaper article, but this was some kind of like Obama Q&A, right? And it's like John Boehner tweeted a thing, and then that happened. But John Boehner didn't tweet. Like, he didn't type THAT A circumflex Eurosign trademark S. That's not what he typed, and it's not what was in his actual tweet. There was a character encoding problem. So I think you need to know about this. And so let's go on a tour. Let's talk about character sets first, then come back to character encodings. Okay, a character set is kind of just what it sounds like, a set of characters, but they get numbered. So every character that is a character, if you want to be able to type it, transmit it, display it on the screen, it goes in a list and it gets numbered. So, 65 is a capital A, 97 is a lowercase a, right? Those are different characters. We need them both. The set contained or equal to is 8,838. The Chinese character for, was it something like happiness? I forget. Is that so? The poo emoji. Well, apparently we need the poo emoji because it's the modern world, and that's just how we use computers now. Is 128,169, and of course a bunch more. Or at least those are Unicode character set numberings. There's a bit of a historic tale to be told here. One way or another, early computing work was done in primarily England and the United States, both of which are English speaking. So early days, it was like, well, if we can deal with English text, we're good. We've only got like 3 kilobytes of RAM, so we got to use it pretty carefully. So ASCII, American Standard Code for Information Interchange, it's a small character set. It's 95 characters, and like if you have a standard US keyboard, it's basically the ones you can type. Like A through Z, lowercase capitals, digits, punctuation. That's pretty much it. One character becomes 1 byte, and that's fine. I guess I don't have to. Fine. Just Google ASCII table if you want to see one. You would think I could find a link to an ASCII table that doesn't change every semester. Okay, so somebody bright realized, ooh, okay, so we only have numbers up to 127. Okay, if we're going to store it in a byte, we have half the byte left still. Okay, well, okay, it turns out, again, as history goes on, right, it's like, okay, wait, there's people that speak French and Spanish. Okay, well, we can use the other 128 characters that could be represented in 1 byte to represent like vowels with the thing, or the N with the thing, or whatever. So okay, you go a little farther down the road in Europe and you realize, okay, there's Greek people. okay, but we're out. We can no longer store all of this and the Greek alphabet in one byte. And then you go farther down the road and you realize there's people speaking Hebrew as a whole different alphabet. So we ended up with I wasn't making these decisions. It came to be that we had these separate character sets. Each were 1 byte per character, but they were sort of like mutually exclusive. Like one text file couldn't contain both, accented French characters and Greek characters and Hebrew characters. And then you go a little farther down the road and you realize, oh, geez, 1 byte's not going to do it, is it? Like 1 byte can only hold 256 unique values. So we're not going to be able to do Chinese with 1 byte per character. And then, later on, somebody's going to invent the poo emoji. So we have this like second system thing of like, let's solve this problem once and forever. And this is what Unicode is sort of endeavoring to do. If you don't know what Unicode is, have Joel explain it to you. This absolute minimum Unicode article is worth a look. But basically, have 145,000 or so characters with the current Unicode version, which again, the goal here is every type of writing that humans do, we want to be able to represent that. So what do we got? We have Cyrillic, Hebrew, probably Arabic, Bengali maybe, and like some math symbols, like all of these things that we want to write down. All of these are Unicode code points, which is basically characters in Unicode. If you're interested in such things, there are these various tables of them. I don't know what we want to look up. Let's find out what that Chinese character I used a few slides ago was. Here, that would be another thing that would be easier in person. Yeah, happy, glad, etc. Enjoyable. So like I said, it has this code point, 63,000 whatever. I'm sure I got it right on the slide too. Great. What I don't have in this part of the story are any bytes yet. All I have is this like ideal list of numbered characters that exists in some standards document. I need to translate that into bytes because bytes are what I need to, send over the wire. So that's what an encoding is. Again, the character set, list of characters that get numbered. An encoding is how do I turn those numbers into bytes? Again, when it was 1 byte per character, that's pretty easy. Now we have some more choices. We could just say like 4 bytes for each character. That is a way to encode Unicode characters. It's UTF-32. But it feels like a lot, right? Like back here, I had 1 byte for every character. All of a sudden I have to go to 4 bytes for every character. That seems like kind of a lot. And especially as a web developer, like whatever language this page was written in, all of these bytes are going to be pretty much unchanged, right? So I'm still going to have less than meta character set, whatever. And this is the first actual content that might be in Greek or Hebrew or Chinese or whatever. So I'm going to have a lot of ASCII characters there, no matter what, just because the languages are what they are. So I can cut the description short here. There's only one character encoding that a web developer should be worrying about, and it's UTF-8. The ASCII characters, the ones that are most code, HTML and CSS code, are still encoded in 1 byte. That's great. And then other characters take between 1 and 4 bytes in general. So the worst case scenario is sort of still no worse than the obvious thing of just, well, we have this many things and put them in a bunch of bytes. But most characters, most of the time, are shorter. There are other useful encodings for Unicode, but again, I think for web development, this is the choice. I also feel like UTF-8 is my example of like, oh, there's definitely people smarter than me. UTF-8, like there's this folk history of how it was created, and it was like, it was by is it Pike and Kernighan or something? So, I can't believe the history's not. Thompson and Pike. It was like created by them, like on a napkin at a bar or something. Like it was this. These people are smart enough to create this thing that's better than anything I would have created, like on a Friday afternoon. Anyway. Okay. So what that's going to mean is, one, you're going to produce HTML. You're going to produce all of your everything text, UTF-8 encoded. And for me, like that was things like, I don't know, I have a web page here somewhere, right? I implicitly chose this, right? So there was this implicit choice when I saved this file that maybe I should have paid more attention to, that it's being encoded, like the way that the characters I typed are encoded into bits is this way, not any of these other ways. So again, I'd done that. It was the default for my text editor, so that was fine. And then I have to make sure the browser and I agree. And I guess the other place I made that choice was like back here. Again, these in Python, these are characters. So this is a string that contains several characters. This is a single character. It's this, it's the emoji, the Unicode code point that represents a little smiley. So that is one character, just sort of described as a hex value. So I encoded that into bytes this way. That was an important step, or that save as over here was an important step. And then I have to sort of tell the web browser what that is. Like, hey, what kind of bytes are these? How do you turn these bytes back into characters? It's what the meta-char set is doing in the HTML. This is a weird spot for it because you have to decode the characters in order to figure that out. But the hope is that the web browser can at least get that far before it can guess its way that far into the file. Probably, and like I would definitely prefer to have it in the HTTP headers. So like I had done that here. I'd said, hey, these are UTF-8 encoded bytes. And if I had sent something different here, like if these had not matched, so I told the web browser to decode bytes into characters this way, but I encoded characters into bytes that way. Badness happens. Where's my... Everything has gone even wronger than I thought it was going to go. And if I could have said something here like, you know what, this is just ASCII text. That's a character set. And by the way, this character set parameter here is a lie. It's character. This should be called character encoding. The standard for like how to spell this thing came just before it was obvious in Unicode that character set and character encoding were going to be different concepts. When you see this, read character encoding. Yeah, okay. So some of these aren't legal ASCII characters. It did something with them, not something especially correct, just the best thing it could figure out how to do. So point being, what the browser is doing and how the content is being turned into bytes have to agree with each other. If they don't, you get that Obama tweet kind of situation. So yeah, it can be declared, like I don't usually bother in style sheets if I'm perfectly honest. But you can say that, and if you have, especially if you have any non-ASCII text, you probably should. So again, if at all possible, this. Yeah, be explicit. And maybe be explicit like both technically, like in your HTTP headers, in your meta char set, which this is required in HTML5, and just be explicit in your own head. How do we encode bytes in this system? Probably you should answer UTF-8, but you should make sure. If you have ever read a file, and I pray that you have, right? You go into your thing and you create a thing and say, okay, I'm going to write a Python program, and I'm going to say file equals open some file.txt, and then whatever you say, like for line in file, right? There's a character encoding here somewhere, right? So the bytes that are in this file are getting turned into strings, which are made of characters. How? What encoding is being used? And the answer is, I can't tell. It's not explicit in this code. It can be. In any sensible tool, you can say what the encoding is. I think that would then be valid. But don't let the default ride, and you'd better know what character encoding you're dealing with. And C programmers, I know that there's this type called char or char, however you feel like pronouncing it. And in C, unfortunately, that means byte. It really shouldn't. A byte and a character are not the same concept. So this is how we get here with this over here. In Python, fine. So this was the tweet. This is the string that's in question here, right? It's this right single apostrophe character, which of course, depending on your editor, your Twitter client or whatever, I feel like John Boehner might draft tweets in Microsoft Word or something, and then a staffer actually knows how to use it. But this is what, again, implicitly happened somewhere along the line. This string, again, string made of, I guess, this collection of characters, string in Python contains this character. You encode that into bytes. Again, like whatever piece of software is in the mix here, encoded it into those bytes. So again, these ASCII characters are 1 byte each, and then this byte that's hex E2 and 80 and 99, those 3 bytes are representing that apostrophe, and then the letter S at the end. So that's UTF-8 encoding. It just is what it is. If we take that and then decode it correctly, great. We'll get that back. What happened in what happened in this case was this Windows. It's a Windows equivalent of ISO 8859-1, which is the Western European code page, where again we have like characters that would be useful in French and I guess Europe. I guess you can kind of see that it's a European code page just from that. Encoding and decoding were use the wrong character set, and it's like whoever wrote the software to put this thing on the screen behind Obama probably just accepted some default, right? It was probably the operating system default character set, and that's what the software uses. And again, probably in my example back here, wherever it went, if I hadn't said this, probably there is some operating system default that would get used, and I don't know, I probably should think about that. I really wish, like, I think if I could go back in time, like every programming language that reads files, this would be a required argument. Just how do we turn these characters into bytes? Because you should say it all the time, but you don't have to because it wasn't a default 30 years ago. Or there was a sensible default 30 years ago. Is that a good, I have no idea. Sure, I guess that's a good spot for a break, let's say. So yeah, I'll take a break there, come back, talk about some more HTTP, page speed is the next topic. I don't know, we'll pick up from there. See you in a few minutes. Or I don't know when you watch these videos, immediately, whatever.